There we go. Today I'm going to show you how forensic analysts determine bullet trajectory.
In this episode, we'll learn the methods experts use to investigate a shooting scene, increasing the complexity with each step.
Firearms are used at many crime scenes, so to analyze the evidence that's left behind is very important. Before we can start plotting a bullet's trajectory, we need to know something about ballistics. Ballistics is the analysis of a projectile in motion. Forensic ballistics focuses on firearms-related projectiles. There's internal ballistics, external ballistics, and terminal ballistics. Internal ballistics is what happens inside that gun. External ballistics is what happens to that bullet once it leaves the muzzle of that weapon. And finally, terminal ballistics is what happens when that bullet strikes that target. Understanding these three categories, it's important because they're all related. That bullet that comes from the gun takes a path and then goes into a surface. When we go and testify in front of a jury, we have to educate them. They don't know the difference between a cartridge, a casing, and a bullet, and there are three different things. So what we have here are unfired cartridges. These would go inside of a weapon, and then when they are fired, they are separated into different components. So now we're looking at shell casings. After we fire that cartridge, this is either going to remain inside the weapon or be ejected out of the weapon. When that cartridge casing is fired, the bullet is going to come out of the barrel of the weapon. This bullet is in pretty pristine condition. I believe this one was fired into a tank of water and recovered, so we don't see a lot of deformation on it, but I do see the rifling on that bullet, so I know it was fired from a weapon. As these bullets strike different targets, they're going to deform in different ways. They flatten out, they hit an object at an angle and are dented, or they pass through something soft, like this bullet and that bullet, and then sometimes when these bullets hit surfaces, they will fragment. When we're at a crime scene, tasked to determine if we have ballistic trajectories or if we have ballistic damage there, the presence of a bullet, especially a bullet that's been damaged, could help us in figuring out whether that damage was created by a bullet or from some other means. Next up, we're going to show how these bullets show up at a crime scene. Now that we've seen cartridges, casings, and bullets, let's see how they affect our crime scene. So when we encounter ballistic damage at a crime scene, we want to first figure out if we have a hole, what is the entrance and what is the exit. So if we look around the perimeter of our entrance, we see a dark substance. This is what's called bullet wipe. As that bullet travels down a barrel, we have burnt gunshot residue and residue inside the barrel that's being picked up on the bullet as it travels from the muzzle of the weapon. And as it passes through our surface, it wipes that residue off. So if I had a bullet that enters on this side, exits on that side, re-enters another surface and re-exits, I could tell which side it entered first because it doesn't have any more residue to wipe off. With the exit, we could see here that the fibers of the wood are going in the direction of the bullet. Plywood's a little different than solid wood would be, but with this or with metal, we would see that substrate pushed in the direction of the exit. Where on the entrance side, we would see it pushed in. So when I look at this bullet hole entry, I could tell its directionality. Understanding directionality is one of the keys to figuring out what happened and how it happened. What I see is the parabolic shape of the bullet as it first comes in contact with the surface. And I know it's traveling from left to right because of that U shape. Another clue to directionality for us by looking at this is on this bullet hole where the bullet doesn't actually penetrate the surface but glances along it. You could first tell directionality by first looking at that U shape, that parabolic shape. And then what we also notice is that the shape is very symmetrical on the front of it. But as it's traveling from left to right, it becomes asymmetrical. So that bullet is being deformed as it's moving along the surface, creating this asymmetrical damage. We just talked about directionality as it relates to entrances and exits. Now we're going to add a layer of complexity to it. So on the car door, we can see that bullets are coming from a couple different directions. So we can tell these are all entrances because the way the metal is deforming in the direction of the bullet. We have very circular entrance holes here, here, and here. These shots are coming pretty straight on, perpendicular to that surface. With our bullet hole entry that's going from right to left here, I know it's going that way because of certain key clues. What I'm looking at is the point that the bullet strikes the surface first and creates a shoulder that goes into the car door. So another key to directionality on this first bullet hole entry is that we have an area of preserved paint right at the edge here. So that's called a pinch point. So the pinch point is where the bullet first comes in contact with the painted door and It's preserving that area, and then as the bullet travels further, in this case from right to left, it's going to enter the car door and create damage. So we see that the paint has flaked off around it, but it's been being preserved right here where the pinch point is. Next, we're going to calculate the angles in which this bullet entered this car door. At a crime scene, we measure out the specific location of each bullet hole entry and ballistic impact mark, fixing it to the world. So from the ground to an edge of a door to a wall. This is used quite frequently in shooting reconstruction cases where we want to show where that bullet is coming from. So this can be time consuming on big scenes where we have a lot of evidence. We may want someone who's just trained in this to do this sort of work because this could take hours. First, we're going to calculate the vertical angle. We use an anclometer or digital anclometer to get this measurement. So right now, we have a measurement of 10 degrees downward. Next, we're going to calculate the azimuth angle. That's the left to right or the right to left angle. So what we want to do is place our 0 point of 90 degrees. There's a line there, lining up exactly where that bullet strikes the surface first. I'm going to have Jonathan come in and give me a hand with this. Next, we're going to take a plumb bob, and on the interior side of that angle, we're going to drop it and hold it alongside our zero-base protractor. Our line is striking the zero-base protractor at somewhere around 23 degrees. We would document this as traveling from right to left 23 degrees. Now we're going to attach a laser to the end of our trajectory rod to visualize its trajectory. This is used quite frequently in shooting reconstruction cases where we want to show where that bullet is coming from. So in order to see this and document it through photography, we're going to have to dim the lights. So I'm spraying along the line. And if I was photographing it, I would do a long exposure, so this would be captured over time. Another method to show this trajectory line would be to reflect light back towards the camera by reflecting it off a white card. And over time, if I did a long exposure, I could show that line. So if I had this as evidence at a crime scene, our bullet hole entries, we'd put a trajectory rod in for each one. The more ballistic damage we have, the more work it's going to be. If I had a case, let's say, where a bullet came through a window and struck a wall but didn't enter the wall, I could do trajectory with that with string. I'd attach one end of the string to the damage on the wall and then bring that string and run it through the hole in a window. And that also would give us the area where that bullet came from. The advantage of string is that it's easy to photograph during daylight, where the laser, we'd have to make the area dark, and then that's not possible when the sun is out. We just finished with lasers. Our next step is to use the 3D laser scanner. So we're going to be using the Leica RTC 360 to capture our crime scene. So the laser scanner and with the Leica software, not only can we get very precise measurements, we can also get those same angles that we calculated with the trajectory rod. So we're going to set up our laser scanner in 2 different positions and scan this scene. After we scan the scene, we're then going to import that data into software so we could visualize our point cloud. So now that we have our 2 scans, we've imported it into our Leica software. Anything that's in the view of the scanner is going to be captured. So you could see us offset here. Here's me. So the RTC 360 could take about 2 million measurements per second. So as it spins a full 360, all these measurements will look like one large point cloud. The beauty of laser scanning is that unlike a static image, we can move it around, we could view it from different angles, we could see these trajectory rods that we have in place, and we can get novel views of the scene that we couldn't get with traditional video or photography. And one of the great things about laser scanning is that it's objective. Any other type of measurements that we take at a crime scene, I'm choosing to measure from 2 points or 3 points to this evidence. With the Leica scanner, anything that's in its field of view, it's documenting it. So we may not know that something over here is valuable and we don't collect it, we don't photograph it, and we miss it. But later on, as our investigation proceeds, we find out, oh, this was really important. At least it's captured with the laser scanner. What also we could show with this is our cone of tolerance. So with trajectory analysis, there's a built-in plus or minus 5 degrees of error. With this software, I can show that error. So I've created a line from 2 points on that rod, and now I could take that line and extend it out into space. And sometimes in real crime scenes, this becomes very important. I had a reconstruction that we did where a bullet went through the 13th floor window of a business and then wanted to see where that bullet came from. So we scanned inside of the business and in several blocks around it on the street, and we were able to trace that trajectory about 800 feet away, 2 blocks away from the location. So today we talked about the basics of ballistic analysis. These skills are built over time, taking hundreds of hours of courses, more scenes, more experience, the better you get at it. Hopefully our viewers have a better understanding of shooting reconstruction, as well as the physics, math, and science behind it. I find bullet trajectory fascinating, and I hope you do.